How are you?
Okay.
Okay, thank you. We'll start now. So basically, today I discuss about some advanced topic on remote sensing. How we can easily make the supervised and unsupervised machine learning in R programming. And previous day I discussed about that how we can easily work with satellite imagery and create the different types of composite. Okay, so let's go. Let me share my screen. Okay, can you see my screen? Okay, thank you. Okay, so first of all, I just simply show you that previous topic. Then we start for our main topic for today's session. So for the first day, we discuss about this type of code. So basically, first code is the get directory. Suppose in R Studio, always it connecting with your directory. Directory means that your connection, okay, or catalog. Okay, suppose your catalog which folder is connecting with your R Studio. Okay, so it's called that get directory. So just simply write getwd, then simply run it. Then it show you that your get directory. So in this case here you can see this is my directory. Okay, so this is my directory. So in this case, all of file from this directory I can easily use. Okay, so now my RStudio is connecting with this directory. Okay, so in the document folder, then this is my folder I created, R for remote sensing. And now further, if I just check the main directory, suppose just same things. In this case, just I take a variable and store it this function. Okay, and then I run the code, I can get the same result. You can see that the same result. So now if you want, you can create the directory. We also discuss about that. Suppose I can create a folder, I create a new folder. So for that, simply take a variable name and then just put your folder name. Okay, so just put the folder name and then put here the directory create. Okay, then put here the name. So then this, it create a folder for this name. Okay, just use the name, folder name, R for remote sensing, and create the new folder. Okay, and further we can simply set this folder as a main path, mainly main directory. Okay, so this is the process we already discussed about that. So in this case, this is our main we already create this folder, and if you check the folder from here you can see, so this is the folder about that. Okay, in this folder, this is my directory, basically R for remote sensing. So this folder is connecting with my, this is the process. We can simply directory connect our directory or create the new folder, and this new folder we can connect as a main path or main directory. Okay, so in this directory, first class I already discussed about that, mainly Terra. So it's one kind of Python R package. So using this package, we can handle the different types of raster imagery, mainly TIFF format imagery. We can easily handle, mainly read, write, this type of things. We can easily do using the Terra. It's one kind of R package. So here I just simply import this R Terra, and then I simply take a folder B1, B2, B3, B4, B5, B6, B7. Okay. So now it just I put the file name. Okay, B1.tip, B2.tip. So then we simply run all of code. We already discussed about that. And when I just print suppose B5, so then I can get all of information for the B5. Okay, so I can easily get it. You can see all of information. It's class, mainly this class is that um special raster dimension, mainly x and y, mainly row and column number, and layer mainly how much band connect. So in this case B5, this variable is stored only for the one band, so that's why it show the one. So this type of things we already know about that. Then CRS we already know, NCell, DIM, resolution, then layer we can easily check, as well as we also discuss about that compared geometry. So compare geom. So basically it's compare B1 and B5. Is it same spatial resolution, same cell size, or same georeference is not or true or false? So just simply use this function compare geom and then put your band name B1 and B5. So now just we compare these two raster imagery. So then we can easily find out this compare these things. You can see it loading. So then you find out the true. It means that B1 and B5 mainly these two bands, they are the same spatial resolution, they are the same extent, they are the same cell size, everything is the similar. Okay, as well as we also discuss about that band combination, how we can easily create the band combination. Suppose I just use B5, B4 and B3, just I create the three band and create the one combination. So for that we can easily create it. So in this time you can see find out that band name B5, B4 and B3, layer name mainly 3, because in this case I just take only for the 3 band. As well as we also discuss about that, suppose I just take only for the B, basically you can see all of bands are the same name, first letter is the B. So just I put here the B, and then I mention 1 to 7. I just make a list 1 to 7, and then I put here the extension dot tip. So now if I run the, then we can easily get it. It create all of bands together. Okay, all of bands together, and then I just simply use the rust function. So basically it create the combination, it create the just combination all of band. Okay, so just I take a variable land set, and then we just put the rust, and I want to create the rust using total 7 bands, mainly 1 to 7 all of band, this data set is stored. Okay, so just I run it. So now we can check it. Okay, let me run it. We easily find out, you can see we find out that this type of result, total 7 bands, we find out that B1 to B7. So further we also discuss about that how we can easily create that RGB, or also create the FCC or agriculture or band combination. We discuss about the different types of band combination, and further we try to display this type of band combination. Okay, so today's session I discuss about that how we can easily apply the, how we can easily extract the suppose spectral signature. Okay, suppose a spectral, what is the spectral signature? A spectral signature indicating about that your mainly your band pixel value for a specific point or a specific location. And it's very important because spectral signature are the unique. Okay, for the specific feature we always find out that unique spectral signature value. Suppose for water we find out that same spectral signature value for the vegetation, for the water body or build up barren land. So spectral signature values are unique values for a specific feature. So that's why it's very important to work with spectral signature. So okay, let me show you this. It also loading. Okay, it will be loading. So then I talk about that after loading. Just a minute. How we can easily extract the pixel value in DVI. Okay, so you also try for EVI survey. And I already discussed about that for previous class, as well as also discuss about that how we can easily create that histogram. So you also try for creating the histogram, this type of things. Then how we can easily apply the thresholding technique and extract the vegetation. We already discussed about that, as well as how we can easily use the different types of friends and then make the NDVI classification. So now I discuss about that. Here you can see I already imported this shape file. Okay, so basically when you work with the shape file, then we need to work with one library. This library called as the SF library. Okay, so this SF library basically handle the data, shape file data. Okay, basically vector, point, line, polygon. So thus I simply import the SF library, as well as also I take a variable sample and I simply put this name, land use land cover sample.ssp. So this name I simply put in here, and then st read. So basically when you read this shape file, then we have to use the st read. So then I read it. Okay, so now it will be read. And further, okay, so it show that file does not seem to exist. Okay, so let me run the code properly. So just I run it and also run it. Cannot open. Okay, so let me just call this variable name. Okay, it's also open. There is no problem. Yeah. So here you can see, find out that it's total 25 feature. Okay, we find out the 25 feature, and we find out that all of geometry type is the polygon. Okay, and this is the bounding, and this is the coordinates difference system, and we find out the class 0, 1, 2, 3. Suppose 0 for water, 1 for vegetation, 2 for build up, 3 for barren land. Okay, so then we can easily read it. And further, I also want to work for that. I want to extract the pixel value. Okay, suppose I want to extract the pixel value. So for that, extract the pixel values. Okay, so now total 25 feature. Just I need to extract the pixel value. Okay, so pixel value mainly in my land set, this variable. So what is the land set? If you check the land set, I already defined the land set. Basically, land set is the combination all of bands. Okay, this is the land set. I already create the land set. Basically, it including total 7 bands combination. So if you check the land set again, so you can see all of band. We can easily find out in here. So then I want to extract the total 7 bands pixel value for my 25 feature. Okay, 25 feature. I want to extract the total 25 feature. I want to extract. Okay. So for that, I just simply import a library, a raster library. So raster is the another library. So basically, this library also help you to work with the tip imagery. So then I simply import the raster library and I call the raster and put the land set. Basically, land set is stored total 7 band combination. And then we just sample data. We just make the special mainly we take the data. Okay, so for that, just we simply put here this point sp. I take a variable, and then I just simply values extract the values from r mainly it stored the land set imagery, and point sp basically it stored the sample data. And then further, suppose I just run it and also show the values. So now it extract the all of pixel value. Here you can see. Okay, for total all of bands, we find out the spectral signature value. Spectral signature value we find out from here. All of spectral signature value we can easily generate from here. Total 25 feature. Okay, total 25 feature. We generate the spectral signature value. And further, suppose you want to save the value with your shapefile. Okay, so for that, just use the function stwrite. So this function help you to save it. So just I simply call the sample data and I put the file name. So further, when I just run it, further suppose I want to just plot. We find out this type of imagery. Okay, and I also want to plot the all of data, mainly our mainly point data. So you can see it also generate some point. Okay, so basically this type of place I just use for taking the training sample. Okay, and it extract all of the pixel value, all of those pixel value extract from here. So now we talk about that how we can easily apply the supervised and unsupervised. Okay, so first of all, it is about that unsupervised classification. So you already know about that unsupervised classification. We don't need to put any kinds of training sample. Okay, just we simply use the band. It automatically calculated the many clustering and find out the similarities between the pixel value and make the classification. Okay, so let's go discuss about that unsupervised classification, how we can really perform in our studio. So basically, in this case, we try to use this same imagery, basically our the same imagery, select imagery. So if you just simply import a library, Terra, and further I simply call the names. Okay. So if I just call, suppose just simply print land set variable, you can see land set variable, just I call. So here we find out that this type of name you can see. Okay. Postal band, blue band, green band, red band, near infrared band, short wave infrared one band. Because in this case, I just rename. I just rename. So just I call the name column. It's my name column. So if you check previous time, suppose from the Landsat imagery, it was more better. So previous time when I just make the data set, I also print the Landsat. So it shows that coastal blue green red infrared, because in this case I rename it. Okay, so all of band I just rename. Okay, so and how I can rename, for remaining these things, just I use here names function, names, names, because you can see it's the names. Okay, names, and then put the land set, then I just make the all of band name. Okay, so this is the one kind of process to rename your band, because if you check my file, this band name is the B1, B2, B3, B4, B5, B6, B7. So now I want to rename this type of band. So for that, I simply use here the names and call this Landsat variable, because Landsat variable is stored all of band. And now I just make the new name. Just I make a list all of my new band name. For the B1 is the coastal, B2 is the blue, B3 is the green, B4 is the red, B5 is the near infrared, B6 is the short wave infrared 1, and B7 is the short wave infrared 2. Just I make a list all of band. And further, suppose I want to use this type of band and calculate the NDVI, meaning normalized difference vegetation index, I want to calculate. So for that, in this case, in unsupervised classification, here I use the reflectance data, but we are not supplying any response data. Basically, we are don't identify any pixel, okay, because it's an unsupervised classification. So that's why in this case, we are just use a band. Suppose in this case, I just use here the k means clustering algorithm. If you want, you can also use the other algorithm, different types of algorithm. So I will show you that for the k means clustering, and I will perform the unsupervised classification on a special subset of NDVI layer. Suppose I just create the NDVI, and this NDVI, we just use this type of band. Okay, so for that, for making the NDVI, just I take a variable NDVI and I call the land set, because this variable is stored all of band. From the land set, I just call the near infrared band, minus land set, I call the red band, divided by I call the land set near infrared band plus land set red band. So just I put the equation land set near infrared minus red divided by land set near infrared plus red, and then I calculate the NDVI. So just run the code. So now we find out that NDVI. Okay, if I just print the NDVI, then we can easily get it. It is the special raster class, and we find out that one layer. Okay, so it's create the NDVI, and now from this NDVI, just I extract the data frame. Okay, so after creating this NDVI, we are just convert the raster to the data frame. So this raster NDVI is the raster image. So this raster image just need to convert into data frame. So for that, for converting the data frame, just I take a variable nr, and then I put here the as data frame, this function. So this function help me to convert the raster to a data frame. I have a raster. I already make the raster of NDVI. So this raster I convert into data frame. So for that, I simply put the function as data dot frame and call the NDVI and cell equal to true. And further, if I just run it, so if you want, you can also check the str. And we check the structure about the data, str about that nr. So now run the code. We can easily find out. You can see data frame. We find out that two variable. Mainly in this case, we find out that data frame look like that. how much object in here in our data frame, and two variable we find out that cell and near infrared it show about that. And now we find out that cell number. Okay, cell number. So if I just print it, suppose just without str, just I print it, so then you can easily get, you can see all of details, all of data details you can easily find out from here. So it display the all of cell. Okay, cell number we can easily find out, mainly cell. Okay, and I find out the value of ndvi value, we find out that all of cell including with their values. So now, after converting the raster to a data frame, just we use the, now we'll just apply the k-means clustering on the matrix. Okay. So in this case, for k-means clustering, first of all, it's important to set the seed generator. Okay. We need to seed generator. We need to put in here. So seed generator, it's one kind of important item for the k-means initiate with the center in random location. So for that, I just put here the set seed 99% we take. And then for the k-means clustering, create the 10 clusters. Suppose you create the total 10 classes. Okay. You create the total 10 classes and you apply the suppose iteration 500 and start with 5 random seed using this algorithm. It's one kind of algorithm. So for that you can see, I just call the k-means cluster and I just call the k-means cluster function. It's one kind of function. So in this function, I just call my data frame, which I convert already from raster. Just I call it, and then I center. Basically, I put the center is the 10 cluster. So basically, when I apply this unsupervised classification, we find out the total 10 classes. It automatically create the 10 class, and I put the 500 iteration max. I put here the 500, and we put here the start with 5 random sets using this algorithm. Basically it's called the loyal 8. This algorithm, you can see this algorithm is the loyal. So this algorithm will also apply in here for that k-means clustering. So just I run it and also get all of information about the k-means clustering working. So you can find out this type of result. Cluster, basically find out this type of value. Center, we find out that basically 1 to 10, total 10 classes we find out. And we also put here suppose number. Okay, so different types of information, find the size, iter, then ifold, all of those things can easily get in here for this cluster. So after creating the k-means cluster, k-means returns an object of class k-means, we find out in here. And now use the ndvi object to set the cluster value to a new raster. Okay, so just we are use the ndvi, we already make the ndvi. So this ndvi to set the cluster value to a new raster. So further just I take a variable and call the rust and put the ndvi, and I put the new layer about that. And further, after doing these things, we are just check all of things. So just I tell all of, you can see find out that this is the class mainly a special raster, and we find out the dimension. It's a dimension, is resolution. We find out that extent. We find out that, then we also find out that coordinate reference system, latitude, longitude value, and we find out the mean a1 and max 10. So it create total 10 classes. Okay, total 10 classes created. So now we can see the knr is the special raster, but we don't we is 1 to 10, we don't know. So for that we are just use here the total 10 color. You can see just I take a variable my color, and then I make a list total 10 colors. I just simply put here the total 10 color list I put in here. So then I simply run the code after adding the color, and then I just create the plot of ndvi. So I create the plot of ndvi. This is my ndvi plot, and I also plot the after k-means cluster. Okay, I'm in the unsupervised classification. I put the, just run it. So now we can easily find out this type of map. So this map is generated from the k-means clustering. Okay, so further you can see we can easily generate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just we are applying the unsupervised classification based on the NDVI pixel value, and we can easily generate this type of 10 classes. We can easily find out this 9 number class is for water. Then you also find out that this type of 1 number class, it's indicating about the build up. Then you also find out this 2 number class indicating about the vegetation. Okay, and also barren land, this type of class in class number 3 is the barren land. So this is the process to work with k-means clustering in R studio. So k-means clustering, we can easily get it from here. Further, if you want, you can also calculate the area. So I will discuss about that, how we can easily calculate the area of each classes and how we can easily check the accuracy. So this type of things further I'll also discuss how we can easily work with that. Okay. Suppose in this case, I just put here the cluster number 4. Just put here the 4. So now it create only for the 4 classes. Suppose, let me run the code again and show you the result. I define the all of color. Okay. So now it create only for the 4 classes here, I can see. Okay. You can see, we find out that only for the 4 classes. So basically, if we find out this type of classes, only for the 4 classes. Suppose I put here that iteration center. Suppose I create the 25 classes. Just put it the 25. So now it created the total 25 classes, and it's an unsupervised classification. So that's why we don't know which class I got from here. We don't know. So now it created the total 25 classes. Unsupervised classification. It's working. So now I can see it created the total 25 classes. Okay. Can you hear me? Yes, sir. Okay, okay. So if you have any question, you can simply ask me. So now we talk about that how we can easily work with calculate the area. Suppose I just create for total 10 classes, 10 classes from my clustering. Now I want to calculate the area. Suppose I want to display only for this supervised classification. So for that, simply click on here, clear all plots. So now it will be removed. I just yes, and I just run only for this, only for this. So now it create only for the map of unsupervised classification. So now I want to calculate it all of area. Suppose for class 1, how much area? For class 2, how much area? For class 3, how much area? So I have to calculate the area. Okay. And when you calculate the area, first of all, we need to ensure that data is projected coordinate system for accurate calculation area, mainly UTM projection we need. Anytime when you calculate the area, For any raster data, you just need to make the data for your UTM projection. Okay. So now, but we already check it. You can see it's about that WGS projection. Only we find out the WGS projection. But when you calculate the area, suppose I want to calculate the area, calculate the area. For calculating the area, always we are just use here the projected coordinate system. So how I can convert the projected coordinate system? For that, just use here the LULC. I take a variable LULC, suppose raster, and this variable I just convert the projection. For that, just use here the project raster. I use the function. So basically, this function help you to convert the projection geographic to UTM zone, mainly projected coordinate system. And I want to do the projected coordinate system for my map. And my map is stored in this variable KNR. Just I simply copy the KNR and paste here. Okay. And now I just put here that CRS equal. I put here CRS. Okay. And now I just need to define my projection. So for my projection, you can easily get the projection. Suppose I simply search on the Google. Suppose for Dhaka city UTM zone projection, we simply copy from here. You can simply search here EPHG.io. Simply go to this website, and from this website you can easily get this type of information for your projection. Okay, so simply search your study area. Suppose I simply search here, I need for Dhaka. Just I simply put here and then search, or you can search any place, any country. So here you can see, find out that is Bangladesh, Dhaka zone. I try to use it. Dhaka. We find out this type of information. Here you can see the one information is that copy format, download, copy, open. Okay. Map server. Okay. Map link. Geo server. This one. Just I copy this URL. And further, let me just paste here. Okay, no, it's not copy. Just a minute. Let me just copy from here. So here you can see. Just a minute. Let me check. Just I copy from here. These things. Just copy. And further, I want to mention it in the CRS value. Just paste here. Okay, so now it convert. Okay, just I try to put in here CRS and run it. Okay, so it show that number of column matrix C5 error. If you want to also suppose just it's I think it's some problem in here. So we are just put here the project uh, UTM plus zone equal for Bangladesh 45 or 45, yeah, 45 we define, then plus term equal WGS 84, then we also need to mention here plus units equal M. So now try to check what happened. If the number of column matrix must, well, we tried next suppose. So let me count for pixel. Suppose for the pixels, put here the suppose pixel counts. Pixel counts, I take a variable and put here that FREQ frequency and call the LULC raster. So the error is the evaluating X selecting. Okay. Let me directly calculate. Suppose KNR. It's worked. There is no problem. And if I just put here the pixel counter, so I count the pixel for that for one class, how much? For two class, how much? Total 10 class, we find out that all of count pixel count. Okay. And further, we are just calculate the pixel area. So for calculating the pixel area, suppose square meter we calculate in here. So for that, just I take a variable, suppose pixel area, and I calculate the, I put here the resolution. Basically, it's come from this come from that KNR. It stored my land use land cover map KNR, and put here suppose I put here 1, then put here the multiply with RES and mention here KNR at that suppose 2. Okay. So now if I just run in the code and if I just pixel area, so we find out that this type of information. And further title I need to define suppose X column, X equal, I put here suppose LULC class, Y column, Y equal, I put here suppose I put here suppose area in suppose hectares. Okay, we need to use here comma sign. So this type of information simply added in your map. Run it. We can find out. We can see LLC area distribution, area hectares, land use land cover class. Also get the class. If you want, you can also add here the more item. Suppose I just put here the plus sign and add here the theme. Theme minimal. Minimal. So now this map look more better. So now run the code. We can find out this type of. It's now we find out this theme is look more better. If you want, you can also add that position. Suppose just put here the theme, put the plus sign, and put here the theme, and I put here the legend position. Legend. If you want this list, then you can write right, bottom, or center. I put suppose legend dot position. I put here suppose I remove the legend. Suppose put here the none. So now I can see there is no legend. Suppose I need the legend. just I open it. Suppose I put at the legend position in the left, not the left. I need the legend position, suppose right. Put at the right. It's to the right. I need the legend position, suppose top. You find at the top, you can see the top. Or any, suppose bottom. Find out that bottom. Okay. Or if you don't need the legend, just put at that none. So now it show there is no legend, just only for the bar column. Okay. So this is the process. And if you want, suppose this chart I want to convert as a pie chart. Okay, so I want to make the pie chart. So this process you can apply for any land use land cover area or any time for creating any data frame as a any data frame, it including any different types of data. So we can easily display it as a. So now it was about that pie chart, how I can create the pie chart. For the pie chart, just I show you that how we can create the pie chart for our data. For the pie chart, same process we apply. Okay, just I copy the same code. Just I copy the same code from here. Something we need to change. Otherwise, all of those things are the same. The first one is that land use land cover. It's okay. AES mainly X and Y. So in this case, we are not put the class. Okay, just I put at the blank or empty. Just I put the empty sign, and Y is the area hectare, fill is the class. Okay, and then geom bar we put the state identity, and also need to mention another item width. So put at that width width equal 1. Just I do it, and then further use the plus. And another important thing is that mainly your code polar. So we also mentioned about that. It is that CORD code polar. So put at that code polar. Put at that Y. Okay, code polar. We define the Y. Y mainly hectare. It's including all of area in hectare. And then okay, so then further I just remove all of those things and show you that first code. Okay, so now let me run the code. So now it create this type of circle. You find out that. So mainly same process apply. Just simply put the empty, and also width plus 1. You can also increase the width. Then we can find out that more width in here. And chord polar put at the Y. Y mainly it's our area. Y is the area. And further, if you want, you can also add here the title. So for the title, put here the labs argument we put in here. And for the title, I put here the suppose title. For the title, I want to mention here LULC area, suppose properties. Now this title is also added. We find out that. And then you also look more better. So for that, just put here the theme void. Suppose theme. I mention here theme void. Okay, so now it also look more better. Oh, pull up which are the plus sign. So now you can find out this type of result theme void. If you want, you can also remove the legend title. Okay, so for that, just put here the plus, and I put here the theme, and I mention the legend dot title. Put here the element blank. So now this legend is also moved. Okay. So now you can see there is no legend, so only can get only for this type of things in here. And further, if you want to save it, suppose this plot I want to save. This is the one way to save. Just simply click and save it. Or if you want, you can simply save it, write the code. For the writing the code, just put here GG save and put this file name. Okay. Suppose I put the file name is that LULC area. PNG. If you want to also mention here the width, suppose width for 8, and suppose height, I put the height suppose 6. So now it will be saved. This graph is saved as a PNG file format. Okay, so now if further you can check the file, we can get, you can see LULC plot, save it in our directory LULC area plot.png. So this is the process to working with bar column. After calculating the area, then you can easily get the idea. It working. Okay. So this is the process to working with bar column or pie chart after calculating the area. Just make a data frame and use the data frame for any graph. We can easily do it. And when okay, so this is the process about that. You also try to follow. And basically, when you work with your data, basically your supervised classification, we also try to apply in our class also different types of model. Further, also discuss about that. But for basic idea is that when we apply the supervised classification, first of all, we need this type of library. Okay, just I write the code. Suppose supervised classification. Okay, so in this time, we just work for the unsupervised. For the supervised, we need a library. This library name is that raster library we need. So just put here the raster. Basically, for raster data processing, we use it. We also need another library. It's called the SF for handling the shapefile or training data. We also need another library. It's called the random forest. Basically, supervised classification. We just apply the random forest. So now import all of library, raster library, SF library, random forest library. You can see there is library is not installed in my system. So for that, simply install. Just click on the package, and here you can see the install because first time we work with the random forest. So just click on the click on the package. Here you can see about that install. So the install, just I put here the package name. This package name is the random forest package I need. Okay, just I put and then install. Okay, it installing. Okay, it's done. So now I need to also import the random forest library. So it's also done. There is no problem. So now, first of all, I need to create the stack image. Okay, load the raster image. You can use the Landsat Sentinel. There is no problem. So just load your imagery. Okay. So for the, I just put here the raster. I take a variable raster. Suppose raster image. Okay. And I already make the, I just put here the stack. Just use the function stack. Stack and call the Landsat because this variable stored my all of band together. So now I just call the raster image I can get, you can see it including all of band, coastal, blue, green, near infrared, all of band is stored in this raster image. So now further, you need to define your path of your training data. Okay, training data, I already make the training data. You can see in the files. I already make the training data. This is my training sample. Okay, so this data is simply call. So for that, just take a variable, suppose training data, and then put here st read. I want to read the data, mainly this shapefile name. You can see lulc lu l sorry lulc sample dot ssp. So this is my data. Okay, further just I simply training data not found. Let me try read. Just I call the training data. Just I print this variable. So that not found. Why? Let me check the directory. Get wd. Okay, you can see here our directory is that R for remote sensing and also another folder R for remote sensing. Basically, now this folder. Okay, this folder there is no data. Okay, there is no shapefile. Okay, my shapefile is available for this remote sensing. So now how I can get? So for that, just simply put here the set wd set directory I use, and further simply copy the path of my file. Just copy from here because this folder is not available my data. My data is available for this folder. Okay, R for remote sensing, this folder. Just like copy and then set this directory again. So now, okay, it show that. Okay, we have to use that the quotation, which is a string. Now run it. So now directory is set. Okay, so just further I simply put here the get wd. We can easily get that our main path. We can see the users remote sensing. So now further I simply import all of things. So just I run the code. You can see there is no problem. Now this file is read. There is no problem. Now this file is read. So now we can easily get our shape file. So basically it's my training sample. And this training sample I already created in my Google Earth engine, mainly shape file. And now these things I want to use in here. So now we need to extract the raster value at training point. We need to extract the raster value for the training points. So let's go iterate to extract the raster value. So just extract the raster values at training points. So for extracting, just I take a variable. Suppose training samples. Put here the extract function. Extract. I want to extract from raster image. Just simply copy and paste here. For my training data, it is stored all of points shapefile, and then df equal, put it to the df data frame equal to true, and to make it data frame for this. And further, if you check land use land cover classes, so now just you need to add the LULC class labels from train. How we can add this? So for that, just I call the training samples, simply copy. And now I just put here that one is that my training samples. I put the label for ID. ID mainly, okay, I put the label for training samples. So it is stored the class. Okay, I put the class. Put here training data. Put here the class. Okay, it show that 25 rows.